Hi, everyone. Welcome to another Common Lisp Study Group. I'm your host, Ram Batum with Atlanta Functional Programming. Today, I thought we'd take a diversion AI to actually cover a topic that's kind of necessary for us to continue progress on that project, specifically from a conversation that we had a few weeks ago regarding generating a Lispier kind of wrapper to write cipher queries. If you recall from our discussion from those few weeks ago, one thing that I was suggesting is that we create a macro to actually go and take a cipher query in and add a new property edge between them to actually allow uh, us to generate a string that can be passed over into a HTTP call that would appropriately give us the 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 cipher transaction that we can actually generate and then just execute inside of Neo4j. A couple of things that arose from that discussion that I found out and recognized shortly after we ended that episode is the fact that of the options that we provided, particularly case one and case two, where we actually um, try to use a regular macro, it turns out that there's some limitations in here that required me to actually move forward and ignore those particular options. And specifically, what I'm talking about is the fact that regular macros is basically using the normal Lisp reader to actually then generate a Lisp to Lisp transformation. And in this case, unfortunately, because Cypher requires inside of the query the parentheses to represent nodes, it becomes a little bit difficult for us to actually um, use just a regular macro to actually do the Lisp to Lisp transformation, since the parentheses have to now both indicate the start of an S expression and at the same time represent a start of a node, so that we can actually use that to generate the appropriate cipher query string, if you will. So I thought today it would be useful for us to review reader macros, because eventually what we're going to have to do is write a reader macro for this. And it's been a while since we've actually covered reader macros and macros in general. So having a good refresher like this is always kind of like a good idea, both for me and for the rest of the folks that are on this stream. Um, Now, we covered macros quite a bit when we did our Let Over Lambda series. I will encourage you to go look back at our previous playlists on that. I'm not going to cover too much on specifics between the different macro styles, but I'm just going to provide a quick review of it before we will actually dive into reader macros specifically. And this is something that I do recall that we didn't actually really do a deep dive on in past episodes, just mainly because of the fact that reader macros is often discouraged for various reasons. And as you will see through today's discussion and deep dive, there's certain particular reasons why that isn't completely unfounded. There is some rationalization behind it. They require some discipline in order for you to use them effectively. And if used incorrectly, reader macros could convolute some code. But if you know when and how to use them, they are very powerful to actually simplify code and make things a little bit more user friendly from the standpoint of a um, molding the language into something that represents the domain that you're trying to, implement your software in. So I thought I would start this discussion with a simple review of the three macros, or technically four macro styles, very quickly inside Lisp. And again, there's plenty of resources out there, of which I do strongly encourage us folks to look at. Aren't Aware is a book that was written by Paul Graham. It's available in its entirety on his website, paulgraham.com. You could get it. The publisher was very nice enough to allow him to actually keep a copy of it, and publish it in the public domain, for folks to download for themselves. And inside of it, particularly chapter 7 through, I think, 15 or 16, he goes through in a fairly detailed fashion how to design macros, how to debug macros, and so forth. But in there, he lists essentially four macro styles that are part of Lisp. And these are reader macros, and we'll just go ahead. Lisp syntax, if you will, and converting them into S expressions, okay, which is Lisp. It's not necessarily Lisp syntax, but it's the form of a Lisp form that's going to be end up being used by the Lisp reader. All right. And this is going to be basically, of the form open paren, some function or macros in which you will actually end up usually specifying a specific character that ends up having to um, invoke the Lisp reader and tell the Lisp reader that this is the start of the reader macro, and then allow it to parse the rest of it until it hits what's called a terminating character to tell the Lisp reader that you're no longer reading the the forms, and we can actually go back to the normal Lisp reader. The next thing is obviously something that we're all familiar with, which is regular macros, okay? And regular macros is basically Lisp syntax to Lisp syntax transformations, okay? And you've seen this um, in normal code. We've actually covered quite a few different ways of writing these. All right. These are essentially the ones that are created with def macro. Okay. These styles of macros essentially are commonly used essentially to wrap around common patterns of abstraction. For example, you may want to, if you are trying to leverage, say, unwind protect to actually go in and release resources and always guarantee resources or um, okay. The next thing that we would probably need to cover is something called the compiler macro. All right, and compiler macros are particularly important to cover too as well. And again, I'm not going to cover all of these in this discussion. We're going to be focusing on reader macros for today. But this is essentially created with something called a define compiler macro notation inside the Common Lisp hyperspec. Okay, and this usually is a as the name suggests, you actually writing essentially a optimization on top of your Lisp form that you're trying to pass in. Okay, so for example, a compiler macro that that is common that's written in the CL HS, the hyperspec, is a macro for say square. Okay, and I'm just going to briefly show this. This is a quick reference from the hyperspec that I think is pretty useful. Um, you might define a function like say square x that goes ahead and looks like my screen is no longer shared. Let me try sharing it again. Um, looks, can folks see that? Um, can folks on the Jitsi call see the screen? Um, try this again. Uh, see this again. Let's say this window share. can um, okay.
Still,
And can
still
can
can't see. It just looks
you
black.
still black? Um, but it says it's sharing my screen still here, so I'm not entirely sure what's going on here. Let me try my full screen then.
I could see it
Uh,
earlier.
hmm, let me try. Let me try. Uh, um, okay, hold on a second. Let's try this. Can you see? Can you see this? My terminal window?
No.
No. Oh, stupid Jitsi. Um, sorry, technical difficulties with Jitsi. Sometimes this happens. I don't know why. Let me close other tabs here, and let's try. Uh,
It looks like it's not working on the YouTube stream either.
yeah, I could see that. Let me try entire screen just for as a as a check. Can you see my entire screen? No, it doesn't look like it's
Oh,
showing up on
yeah.
YouTube screen. You could see it, but it looks like the YouTube stream isn't seeing it.
Well, I think it might be. There might be some delay for YouTube.
Yeah, there is. Okay, hold on. I'm gonna try this one more time. Looks like, let me see this. How about now?
No.
No, you cannot see a window. It's only, this is weird. Huh, okay, so YouTube is actually getting it, um, but it doesn't look like
Oh,
you're seeing it on your screen. I don't know what
I
to
can.
tell you there.
I can
That
just join the YouTube.
okay. That that's fine. I apologize. I don't know what Jitsi is doing today. Um, okay. So let me just get back to what I was talking about, which is this guy. And so when we're talking about define compiler macros, what you could do is given say this kind of function here, you could write a compiler macro that actually takes say this function square and optimizes it uh, by writing a compiler macro that then takes the whole form and this particular argument that's going to be invoking the form, and it allows you to do let's say some expansion and or optimizations on top of it. So like we could check to see if, say for example, the argument is a specific atom, all right, and an atom is just any sort of particular object that is uh, that is not an S expression. It's not a list. Um, and we can then say, okay, if the argument is an atom, just go ahead and call the exponent expansion as it stands today. Okay, and then spit that out. Else, we could then check to see what is the actual list of the atoms. So if it's one or more things inside of it, we could then go through and say, um, we could call the actual square function that we defined, and we can actually then uh, just do like a repetitive optimization, or we can actually go ahead and change the way the evaluation is done. So in the example that's inside the hyperspec, they check to see what the length of the argument is, and if the argument is of length 2, what we then do is we go ahead and then we call exponent on top of the nth argument of the first argument of the list, and we go ahead and take it to the fourth power and return it, and then we'll just return the actual form itself. This is just standard different ways of actually going ahead and updating things. Like, for example, an example of this is if you try and run square 3. All right, so this is just a simple example of this. So um, or hold on, so this one has to go and return the form. So we could just go ahead and do that. And then if we have an actual exponent, okay, if it's an actual exponent form, we could then go ahead and do a different set of evaluations. All this is doing, okay, this code that I'm typing up here is doing nothing more than literally um, allowing you to rewrite the actual uh, form that you're trying to evaluate into something else. Okay, and we'll see in a second how this will work in practice when we call macro expansion on this. Um, so give me just 1 second here. Let me just go ahead and type this up, and we can review this very quickly, and then we can move on to reader macros. Um, so this is then we could do exponent, and then we could just go ahead and do times 2. And in this case, we're actually taking the actual evaluation of the arguments. And then else we do form. No. Nope. No. Hold on 1 second. This is form. That's right. There we go. That's what we need. And otherwise, which is our default case, we're going to go ahead and quickly just spit out standard 2. And there's a compile file. Hold on. Error inside the back quote on column 49 to line 11. Hold on 1 second. I need to see what is the error condition. Comma inside, not inside of a back quote. Oh, sorry. That's what I did. Okay, now we're good. Okay. So the difference is there's some code in here that we'll see when we do this. So like if we run, so we'll run this, we do square 3. You see we get 81, but if we do a macro expand of square x, you'll get square x and false. Now, what's interesting is now if we call the actual compiler macro function, okay, this is how you would end up calling it on, say, square x and then nil, and this will give you your standard exp2 to it will expand to essentially the okay, it'll automatically flatten the squares. So instead of doing a function invocation multiple times, all right, so instead of actually evaluating um, square of x first and then taking the result of that and passing to square. What this compiler macro function allowed us to rewrite that expression into what we would normally do, which is, multiply 2 by 2, get the exponents, and then do a simple call. So this is one way allowing you to write your own optimization passes inside your code so that folks can actually um, understand how that works. And I just noticed that the the technical difficulties there. Um, Let me see if I could do this. For whatever reason, the stream is not doing what I expected to do. So let us go and let me try this one more time. My apologies, folks. I don't normally have this much trouble with Jitsi. Okay, let me go ahead and share that again. And see what happens. And nope, did not. Let me try um, screen. What happens there? Hmm, there is a problem here. Let me see. But get this going one more time. See what it does. Okay. Hold on a second. It looks like the stream is not actually liking. See if this works for a while and then go from there. Okay. All right. So this is just one simple example of, say, a stream connect. A compiler macro that allows you to essentially rewrite exponents. Squares into doing a flatten of flattening of, so to speak, of your power. So this way you don't keep on calling exponent of exponent of exponent. Okay, you don't need now your compiler to go and do that kind of flattening for you to recognize that you're calling the same function n number of times. Um, Again, I'm not going to go ahead and go too much into this other than this simple example, but you could see that this becomes very, very useful for folks who want to say, right, uh, especially optimization passes that could do things like, say, caching and memoization for particular types of recursive functions. So that way, during the course of developing your Lisp system or your Lisp program, those optimizations get evoked by the Lisp compiler at the time that the function is getting compiled, and without having you to run this multiple times yourself. You can actually go ahead and register this compiler macro with the Lisp reader, so that way always gets runs when it encounters these types of things. Again, I will. That's for a topic for another day, but it is something to be aware of, to be on top of your kind of macro review, which again, symbol macros is a another different type of macro available to you inside of inside your the Lisp framework of macros, if you will. And that's specifically useful for, say, being able to um, essentially rewrite symbols um, in um, in Common Lisp. And what does that mean? Well, I'm just going to kind of read what the in the situation of what the hyperspec says on this, because I will be honest with you, symbol macros is one of those um, uh, cases where I'm not entirely sure what in what situations you might end up leveraging it. Okay. Now, to create symbol macros, you have something called symbol macro let. Okay. There is a defined symbol macro in some Lisps. Um, as far it actually looks like, oh, I'm mistaken. Sorry. There is a symbol macro, a defined symbol macro, but normally you would end up using it through symbol macro let. And what it does is for the scope of the actual form upon which you are doing the defining a symbol macro that will look up a global variable that you've defined. Okay, so you could then end up creating constants, so to speak, a list of constants, and then using symbol macros to actually go ahead and refer to those constants that ultimately get rewritten to an appropriate function call into this list. I'll let you guys do a little bit more of it. The reference of here is just basically just looking up symbol macros. Just I defer you to look at for define symbol macro and the hyperspec for more information on this. So I don't pull up too much of a digression of our topic today. So what is it about? Why did I kind of go through this quick overview of this? Well, it's because reader macros is very basically the beginning of kind of this Lisp modification. Like if you're trying to update your Lisp environment in a way that becomes either user friendly in the sense that you don't want users to necessarily know Lisp to actually use your, say, macro language or your DSL to write into Lisp. You can leverage the reader macro to hide the fact that you are actually writing in Lisp and provide them a friendlier, more restrictive interface for them to do a particular set of operations on top of your Lisp program. But then behind the scenes, that gets transferred into ultimately S expressions, and then you can leverage all the Lisp infrastructure that you have up until now to actually uh, provide you with the certain optimizations as well as the obvious convenience of actually using the Lisp standard library where and when appropriate to actually go and execute your particular reader macro, okay, or your particular DSL that you've written on top of a reader macro. Now, to define a reader macro, you have to do two things. You have to define a function that essentially parses the stream that you're getting, and you need to set up a character inside a reader, literally modify the Lisp reader to actually invoke this function when it encounters that particular variable, all right, or that particular character. Now, the Lisp reader keeps track of these functions for invoking different reader macros in what is called the read table. Okay, we kind of covered this when we were talking about named read tables in a couple of release discussions, but I thought I would review that right now. So the read table is already available to you as a dynamic variable here called read table. Okay, if you actually look at this read table inside your Lisp reader, you can see that there's already a couple of um, things related to, uh, excuse me, objects for actually reading in different types of uh, uh, Lisp objects. Okay, one the most common example is if you're uh, starting with a hash function and you start writing out um, a list of vectors. This is actually of a considered an array and not an actual list. Okay, and we could actually see this by just doing, if I remember correctly, um, type of, and then I don't think I can do this. This might, yeah. If you do type of and you actually go ahead and quote that expression, you'll see that it's actually creating a vector instead of what you would see when you do type of and you do a normal thing, you get a cons, all right, which is represented as a list. These types of characters, this hash in this case, invokes a actual reader function. Okay, in this case, I think it's called base character macro array, and it will then read through the stream, generate the actual type of Lisp object that you're creating, and then return it. Okay, we're gonna do something similar here, but we're gonna have to, work our way through kind kind of some basic examples before we can actually start embarking on our cipher query generation of this. Excuse me for just 1 second. All right. So one example that I think would be useful to cover just for this episode is, let's say that we want to create, and this is something that I was reading in the Common Lisp cookbook. Let's like kind of go over the notion of Lisp comprehensions. This is actually from a nice blog post that someone wrote out way back in 2013 that implements Lisp comprehensions using these reader macros. And you can see the importance of what it actually is doing, and at the same time why Lisp and Common Lisp specifically gives you this ability to write these kinds of DLLs so that you could most appropriately represent your problem in the way that is most readable to the programmer that's actually going to read your code. All right. So to do this, we need to first define what it is that we're going to end up leveraging in uh, terms of how it's going to look like. So we're going to essentially write code that would ideally look like this. Um, X for X. We could write it like X for X in um, some list 1, 2, 3, 4. And this is kind of the standard notation that you would see inside um, the this function. It looks like I see that the character again um, disappeared. Let me go ahead and do this again. This little function, weird. Um, why is this causing so much difficulty? Hold on 1 second. Let me see what's going on here. Okay. Let's see here. I'm sorry for folks who are on the YouTube stream. This is highly unusual. I'm gonna probably have to dig into why this is happening more and more frequent now. See this. Okay. All right. Let's see if this, how long this is gonna go. All right. So how might one end up leveraging this? Let's or set something up that allow us to create this this Lisp comprehension, if you will. Well, one thing that we could do is we could first define a function, all right, called, well, let's first go ahead and define groups because we need this. We need to, in order to do Lisp comprehensions, we need some way of doing grouping of a list of into a list of lists, or split it into a list of lists for the purposes of doing some of these comprehensions. Luckily for us, Paul Graham wrote this really nice thing inside um, for us inside on Lisp, and if I remember, it is already available through us through Alexandria. So let's go ahead and load up Alexandria and do Alexandria colon group. No, it's not. Then it must be in Serapium. Give me a second. Let me load up the other utility library that already loaded up a bunch of stuff. Serapium. Let's see if I don't need to. Hopefully, unfortunately, Serapium loads up a bunch of different stuff in here. So let's go here. The heck? Okay. Okay. Now, let's see. Serapium colon. Hold on. Where is it? Let's move this up here. This is not giving me what I expected. Hold on 1 second. Group. Interesting. Okay, it doesn't look like this is available. I'm gonna go ahead and rewrite this. Group and list. I'm gonna use list because I hate people doing that. We're gonna go ahead and declare that this integer, this n is an integer for us. Okay, and now we could then just check to see if n is 0. Go ahead and error out, saying that you can't have a group of length n. That is 0. Okay. Otherwise, then what we could do is we could create a function, an anonymous function here called, well, not an anonymous function, a local function called rec that will give us a recursive function that takes a source and an accumulator, and we'll go ahead grab the rest of the actual list of size n, and then if rest is a cons, then we recall rest and get the subsequence from the source to n, and this gives us a subsequence of length n, and then the accumulator. Otherwise, we reverse we call it, okay, when list, go ahead and do rec list nil. Done. All right. Now we're going to have to go ahead and define our stream function. Okay. Again, what is a stream function? This is standard for all read macros. Okay. You will write, it's a 2-argument function. Okay. That where the first argument is the actual stream that you're being manipulating or reading from, and an individual character. All right. For now, we're going to go ahead and ignore the character. Sometimes we're going to probably have to use the character in some reader macros. In this case, I don't think it's necessary, I don't believe it's necessary based on my understanding of the blog post that kind of illustrated this. Then again, I will go ahead and for folks who want to read that, let me go ahead and post this guy to you guys. This is the reference. And I got it from the cookbook reference for folks who are going to, and I'll post these for folks who are on the stream. I will post these inside the YouTube description too as well. So don't worry about having to pause the video and then copy it. It'll be at your disposal as soon as we are done here. And what this does is this will allow us to go ahead and write a very simple function that will first let let's see how we do this. I think if I do this right, I have to first, oh, right, got it. So we're just going to define a couple of things that has nil. So if you're going to bind something, normally you would end up doing this to bind it to an initial value. But here in this case, we're defining a bunch of nil arguments that are all empty for now. And that represents the results, the sources, the conditions, and the state. And then we're going to read from the stream until we hit some sort of terminating character. All right. So for now, I'm going to be using the blog post used for whatever reason braces because in mathematical notation, our list comprehension really looks like this. All right. Most people know it from Python where we use braces. Okay. And the notation looks like this in Python. And I think in either case we can use it. I'll preserve so that for folks reading this in both the blog post and this, you can follow along to being braces, but sorry, curly braces, but square brackets can also be used if you really want to make it look like Python. And I'll show you how to do that after we're done here. So what we do is we go through this and we read a delimited list. This delimited list is going to use a default delimiter. If you can see here, until some sort of end character. Okay, and it'll keep on reading until it hits this end character, at which point it'll then take each of them and tokenize them and give you a list of all the tokens, right? So here we're making the character curly end curly brace the actual end character that needs to stop reading from the stream, and then we just go ahead and grab the stream and then read from there. Um, oops, sorry, I have to also do that. That okay. Now, what do we do for each item? Well, if the first item is equal to, say, the uh, double pipes, which we're using to essentially indicate the separation between the item and the actual comprehension. Okay, then what we'll do is we'll go ahead and set this guy to being part of the state. Okay, if state on source. Okay, done. Now, let's go ahead and look at the actual state itself. If it's a source, then we're pushing the items of the data into our sources list, okay? Because we're going to later on evaluate all these sources at once, okay? If this is a condition, then what we're going to do is we're going to push the conditions separately on this. These are the restrictions, if you recall, in our list comprehension that we have to deal with. This is like, for example, if we say um, in our if x is greater than 5. This condition here is something that we need to be kind of aware of. Okay, so that's what the condition piece is. Otherwise, what we're doing is we're evaluating, and we're just going to go ahead and push our item into the results. Okay, and that should be it. So yeah, okay. So now we're going to go ahead and set the results to being reverse of our results because we're pushing the items in like a stack. So what we want is the results in the reverse order. We want the sources also in the reverse order and the conditions as well. Okay. Now, for folks coming in who are still not familiar with Common Lisp, please note this is a um, generalized expander, right? So the setf expander knows that it's always going to be variable binding and again expression that you're going to set the variable binding. So it knows that results is going to be this argument, source is going to be this argument, and so forth. That's kind of how the generalized expander works. All right. Um, just a quick review for folks who are just coming in or and haven't seen this in a while. All right, so now we can actually begin doing the real comprehension work, okay? This is all up until now parsing the code to actually set it up for us to do the evaluation, okay? Now what we're going to do is we're just going to create a let binding that will keep track of the groups of all of the information that that we just collected. All right. And these are our list of bindings. Okay. And binds is just going to be map car lambda for a given group. And we're going to do is we are taking the cons of the first of the group and the third of the group. Okay. And we're just going to make them into a uh, a whatchamacallit, a this pairing is used for later on for when we are actually going to do the operational reduction. Okay, and you'll see how this works when we actually put the actually leverage this for our example execution. Give me just one second here. For whatever reason. Okay, here we go.
Hey guys.
Hey, welcome back. So let me just go ahead and do that. And in our map car, we'll just go ahead and do group 3 sources. Okay. Okay. And we're going to just go ahead and then run a map can on this guy that would take the first of our bindings. Okay, and that's going to represent our arguments, if you will. Okay. And what this lambda is going to do is it's all it's going to do is evaluate our conditions as a conjunction, okay, of conditions, which you could put all at once. This is how the comma et does. It does an array expansion into this and, all right. And we know that all of those are going to end up being conjunctions. And then what we could do is then create the actual list, if you will, of the results. Okay, and const that out to as well to our final list too. And then grab the first of these. Okay, and then this is going to be a map car of the cutter of the binds. Okay. So this is our code for the Lisp comprehension. All right. The next thing is hold on one second. Let me just make sure that I think I got a. Ooh, wait a second. Okay, there is a raised hand. Let me see something here. I was seeing a raised hand. For whatever reason, it was. Can you see my screen?
Yeah, we can see your whole screen now.
Yeah, you can see my whole screen. Okay. One of the people that are on Jitsi seems to be having a problem seeing the actual screen itself, which is
There was an
surprising.
issue.
Earlier, we've been having technical difficulties throughout this entire stream today. I'm a bit surprised that it's this bad. Normally, it's not as bad as but this is becoming more and more frequent. I might be forced to actually bite the bullet and spend some time creating my own private Jitsi setup for this to actually work a little bit more reliably. Um, can you see my Emacs window, Alex?
Yes, I can see it now. It was black before.
Weird. Okay, I have no idea why that is the case. All right. So we've set up our reader macro, which again is just nothing more than a function that takes in a stream and a character. All right. We've set up how it's going to evaluate the reader macro, but we didn't actually yet register it. This is where things need to get a little bit, you need to be a little careful here. All right. I say that very, very explicit because for whatever reason, okay, modifying the read table could mess up your Lisp image. Okay. I cannot stress this enough. Um, I'm I'm not saying it. I know the reasons why. It's because the read table is kind of the brains of the operation. Like it has to be able to read in the inputs. So it's the purposes of it you messing with the read table means you kind of need to know what you're doing. And so it's important for you if you are modifying the read table, you explicitly know where to modify it, how to save the read table when you are modifying, and so forth. So there are some examples that you will see where folks would write specific functions where they actually create closures to uh, modify the read table, then use the characters where appropriate, and then essentially invoke it. So exit the read table and restore it. All right. I'm going to show you those safer examples in another session when we start writing up our cipher query. But for now, what I'm about to show you is kind of one way of actually just messing with the read table so that you can actually go ahead and um, uh, see how this particular function kind of works for the sake of example. Okay, just to give you, for folks who want to jump ahead, the functions that you need to be aware of is inside the Lisp read table reader already. There's something called copy read table that will take in the read table, and it's a copy constructor. It will return you a new read table with all the previous read tables, and later on you just have to essentially set F on the old read table with your backup, and you'd be fine. Um, Another thing is given the fact that um, read table itself is a dynamic variable, as indicated by the earmuffs. Um, you can also create a closure that will copy the read table into a new instance of the dynamic variable when you are actually registering your readers, and that also has an option too as well. All right. Um, Let me quickly just do this one thing, which is setting up our read table for our example. And that, the way you do is very simply called by set macro character. Okay. And here you just need to specify the character. Okay. Let's actually go look at what this is showing you. Okay. This is the character is the first argument and the function is the second argument. Forgive me for the completion stuff, but I have smart parens turned on. And so when you open up a brace or bracket, it always does the closing one appropriately. But we only need the single one in this case. And what we could do is now specify a function here that we could end up calling when this is then invoked. In this case, we're calling Lisp comp. Okay. So this will set up the start and invocation of our read table, okay? But we also want to be able to tell the reader when to stop it, okay? And this is also important to recognize. And the way you do that is just do another set macro character. Again, this time we're doing that, but we're not going to write a separate terminating function. We can actually use the same function that's used to terminate an S expression for this, because it's basically saying start the evaluation. And that's already available for us by getting the macro character function from the read table. Okay. And that's what get macro character does. Okay. And it will look up the function that's associated with that, and it will give you that appropriate function itself. Okay. Um, and then let me just make sure that, yeah, okay, good. So let's go ahead and evaluate these two. Okay, so now this should now give us what we want. And let's test this guy out, okay? The way we would do this is we could just do open brace x, x is this. And now we can use any Lisp comprehension, Lisp form to actually do our comprehension. So loop for I up to 10 collect I. Okay. If we run this, it is actually not returning what I it is giving me, I mean, it's running, but it's not actually returning what I expect it to do. Why is that the case? I must have messed up something inside of the comprehension. Hold on 1 second. Did I mess up? See here. Yeah, my notes have it differently. Hold on, let me just copy in my, I wrote this wrong. I'm gonna go to the blog post. I think this blog post, there's a typo in my code. Let's see here. Do we ignore? We do it sources, kind of state. Go through each of the individual stream. We check to see if it's state or condition. Okay, then if it's state, pushes out otherwise. Okay, wait. Ah, yeah, I see this. Okay. There we go. I was actually eating all the part code, but I wasn't actually collecting it correctly. All right, so we can see that this actually ends up generating what we kind of expected. We can actually do Lisp comprehensions up to 10 here. So let's see what happens if we didn't do something like this. You know, we could again grab, say, 1, 0, 2, and we could, oops, sorry, for whatever reason, we could do that. Okay, and then we could see that it could generate 1, 2. And what this is doing here, by the way, is it's assigning and then returning. Do you need this piece here? Probably not. We can just go ahead and do this, and you can see that's 1, 0, 2. But the reason why you had to add the additional X is because this evaluation doesn't give you what you're expecting. As you see here, we're expecting a set of 3. What we're doing here is we're actually saying that we're getting concatenation. We want 1 and 2. We just want where X exists. Okay, so in this case here, we're basically saying X for X is 1, 0, 2. All right, that's just going to give you a list 1, 0, 2. But here we're saying X for X is 1, 0, 2, and X is exists. So it'll filter out. This is the filter mechanism that you'll end up getting inside of your Lisp comprehension. At least the way the reader macro is written, it is. And you can write each of these things, as you can see in this Lisp comprehension design. The conditions are actually separated from the actual code through the use of the pipe operator. All right, the pipe operator is actually, the double pipe is what's separating the two. So for example, if we made this a little bit more complicated, let's say that we wanted to create a the sum of X and Y for X is 1, 2, 3, 4, 5, y is, oops, sorry, y is 6, 7, 8, 9, 10. And what we'll do is we want to add all the even numbers of x, okay, with the odd numbers of y, okay? Give me this 1 second here. I need to move this up here, okay. So when we do that, you can see that it'll go ahead and separate the two and write more complicated Lisp expressions. So this reader macro infrastructure here, and this is kind of what I'm going to probably end today's episode with, is very simple. You write your stream function, you register it, okay, with your into your read table, and then inside your Lisp reader, you'll be able to leverage this, okay? Now, of course, what I've done here is problematic because I've modified the read table, okay? And while in this particular situation, we are not using notation that where a reader exists inside of a read table, okay? Which means we're using a unique character that the reader doesn't recognize as being associated with a Lisp object, okay? There could be situations where we'd want to actually leverage something where a function exists. And this is happening in the case of our Cypher code. And this is why I wanted to bring this up. In Cypher, as I mentioned at the beginning of this episode, the parentheses represents the start of a node, okay, inside of the Cypher, inside of the graph database, which kind of makes sense. When you draw graphs, usually the vertices are typically spheres, right? So they wanted the Cypher code to look like vertices, which has spheres, okay? And additionally, the square brackets could be used for something else, and in this case with Cypher, they're representing properties inside of a property edge and the property graph. So we need to encounter for both of those. But with the current read table, given the fact that parentheses already is associated with read paren to actually start the actual start of a Lisp expression, we kind of hit of a pickle. This is where copy read table becomes important, okay? We need to be able to design an API that then essentially copies the read table, overrides it, runs the parse, converts it into a string, and then restores the read table at the end. One way of doing this is obviously with the closure. You can write a function that says um, read cipher query that takes in a stream and the character, which is basically the reader. And then what you could do is inside of here, do a let, do what I said, which is take the read table dynamic variable and copy the read table that you currently have so we can get all the overrides for the majority of them. But then set your macro character here as being, what is it? Your open paren function, okay, where you do read paren. And then obviously here at the bottom, sorry, set macro character for close paren to being the same as get macro character close paren. And even though this should be really a redundant operation, but I'm just showing this to you for the sake of example. And then once this is done and you've overridden what you need, um, you could then go ahead and call out the compiler function, sorry, the reader function on the Cypher query and return it once the string is completely parsed. Now, I'm still working through kind of how this piece is going to work out in the case of our project for graph databases and creating this nice cipher to Lisp. So really, it's a Lisp cipher to um, string cipher compiler to allow us to write in our Lisp code, just regular cipher code, and then have it appropriately spit that out into our transaction API that we've created. But that's going to I'm still working through some of the kinks on that just to make sure that the functions are a little bit more user friendly and a little bit more um, uh, uh, testable. And we could talk about testing about this at a later time. So that's all I have for today. Are there questions and or comments? And apologies, I know very much so. I've been getting comments on the stream as well as in our Jitsi meeting about the screen sharing and technical difficulties. I will investigate other options on how to do this to see what I can do. Might reach out to a couple of people that I know on setting up my own Jitsi server for some of these kinds of things for future Atlanta functional programming talks. So stay tuned. In the meantime, I'm going to leave you with a couple of things related to just general announcements. One, AFP is looking for speakers for folks who are interested in giving talks. Any talk is fine. It can be functional program. Ideally, we'd like functional programming focused talks, but anything that complements, data processing, data science, as well as things that could leverage functional patterns, is more than welcome at this venue. Just feel free to reach out to me. I am Bugram on Slack. I hang out on the functional programming Slack channel, and I'm also Bugram on the Lisp Discord server. Feel free to reach out to me and give me your talk topics, and we'll get you scheduled. Additionally, for folks who are in the Atlanta area, um, AFP is in need of a new home for its in-person meetups. Please reach out to me and or my co-organizer Judd Taylor for providing suggestions on where we could um, host these meetups, and we will, get them scheduled as soon as we can. So that's it. Any questions? Just going to wait a minute or two from folks who are watching the stream.
Maybe one thing. Hello.
Yeah. Hi. Yes.
Maybe one question I have is apologies if I missed because I missed the previous one. You kind of mentioned at the beginning that you tried to do the Lispy DSL version of it, but that had certain limitations.
Yes. Okay. So in the cipher thing, I mentioned that we could write out a Lispier one where we have a macro called, let's say, define cipher query. All right. And I think I was trying to go with cipher query at the time. Or no, actually, I think it was run cipher query. But basically, at the start of the S expression, you can write out your within the scope of the run cipher query after its invocation, your series of uh, cipher code, and then at the end of the expression, you can go and evaluate it. Now, unfortunately, with the vanilla Lisp reader, this is not possible because, again, read paren has a distinct semantic understanding by the read table with the vanilla reader. Specifically, it's going to say start Lisp expression, unless it's so it always expects that the first item, the first car, if you will, or first item in the list that it parses is an atom or a function. Okay. if it's an atom, it ends up actually throwing up an error because you can't have S expressions that are not quoted are actually considered to be function calls. So it will end up throwing an error. But if it is a function call, then it'll take the rest of the arguments and then run an eval. This is kind of what the Lisp reader does already today. We need to override that to actually say, well, within run cipher query, open paren actually represents a node inside of a graph and needs to be converted into actually just an open paren that's a string that can be passed over into um, the
Well,
actual.
if you have def macro, isn't that going to prevent the evaluation semantics?
It
So inside the def macro, you would be able to turn that S expression with just a list, not
Yes,
necessarily a
you
function
still
call,
end up
into a string.
returning a list that needs to be evaluated.
Yeah, yeah, yeah.
So that's kind of where it stands, right? You would still have to end up doing uh, a format nil, and I have to still recognize that that item that you're passing in is a list some way, right? I need that explicit character to know the difference,
Yeah.
um, to be able to parse it out, which means I still have to tokenize it somehow, right? So you could certainly probably do it with a little bit more of finagling, if you will, of taking the item, but it it if you're going to go through that much trouble, what you'd really want to do is then end up just writing a reader macro to make the implementation much more simpler.
Mm, okay.
Does that make sense? Because you're kind of going out of your way to add this additional behavior while still preserving the def macroness, right? And it does complicate the macro expansion and it could be difficult to debug.
I think I'll have
Whereas in
to.
this particular case, when you have a reader macro, it's done, right? It's an isolated function that says within the scope of this, you're just going to be um, treating this way.
Yeah, I'll have to see the previous video.
Yeah, not a problem. Um, if you come up with a better idea or a better approach on that, I'm all ears. Like this is kind of my experience and my understanding on how this kind of works. But my playing around with it kind of led me to that conclusion. Um, and so I'm willing to learn if I'm making a mistake there. It'll improve my list programming if you come up with a better way.
Okay.
Yeah. I mean, this is what the purpose of the study group is all about. It's, we I'm blundering through it just like everybody else. I give you guys what I'm looking at and I'm hoping people will correct me. So I can maintain my, I'm getting better at Common Lisp just like everybody else. Other questions? All right. Well, then, next week we'll be returning to our regular scheduled program, which is we're going to take this information that we talked about in terms of how reader macros work in our review, and we're going to apply it to actually hopefully getting a first, albeit probably limited, working version of our cipher to string generator so that we can actually clean up our Neo4j code and make it a little bit more nicer. So until next time, um, keep Lisp hacking and, give me some new topics to talk about. Thanks.